tan theta.
Secant tan?
Tan is sine on cos, and secant is 1 on cos. So you multiply that together, you have a sine over 2 cosines multiplied together.
But that's 1 over cos. This is cos squared though.
Right, so the tan has a cos on the bottom, and the secant has a cos on the bottom. So multiply it together.
But they have 2 cos squares in the bottom.
Well, this is just the first one. That's just that part.
Oh, okay.
I mean, that's what's confusing. Hold on a second. So look at it like this. That's just this piece.
Oh, okay. I thought it was the whole thing.
Oh yeah, sorry, no, just that one. And then this one is what? Secant squared. And these you know, right? These are familiar to you as the results of derivatives of certain functions. Here's 1 over cos squared. So those d theta. So what's the answer to the first part? What do you differentiate to get secant tan? Secant. What do you differentiate to get secant squared? No. Right. That's our answer. So when it looks wild like that, you gotta split it into components and analyze each of them. You're not gonna try to undo a quotient rule or a product rule.
Can you explain that first part with this one over cosine, sine over cosine?
Yeah. Carter noticed that sine over cos squared is the same as sine on cos times a 1 on cos. Right? You can view it like that. And that helps because then it comes in a form, if you change it just a little bit, it comes in a form that you know that is the derivative of something. You've got to think about the derivatives you know. You've got to try to construct these things as a derivative you're already familiar with, and then take it in reverse.
But isn't that sine over cosine squared x, cosine squared theta?
It is. So one of the causes we associated with the sine, and one we just kind of moved off to the side.
Okay, so then how did we get from there to the secant theta?
This one?
Yeah.
1 over cos is secant, and sine on cos is tan. So we can write this expression here as secant tan. Right? That's that expression.
No, I'm saying how'd you get from those little 2 parts that you broke down until the answer was just secant theta?
Oh, because once we saw that inside this symbol we have this expression, what does this symbol mean? This symbol says, tell me the function that you take the derivative of to get secant tan. Well, I take the derivative of secant to get secant tan.
Oh,
You sure?
yeah.
Okay. $33. The antiderivative of 1 over 2y. 1 over 2y dy. Since you can move constant multiples to the outside of this symbol, it helps to do that and give you a clear idea of what function you're really dealing with. So write as 1/2 times the antiderivative of 1 over y dy. So what's the answer now?
Isn't it ln?
That's right. Just make sure, again, like I said, it's the ln of the absolute value of independent variable, and then the plus. Okay. That's it. $34. Last one this time, then we're going to do the application part. E to the 2t plus 2 root t dt. 2t, yeah. We already did one like this piece here, but I want to make sure you guys understand how to take care of e to the 2t.
It would just be e to the 2t again.
You're close. So hold on. The 2 throws one dimension to it a little bit. So I'll split it into 2 cases. E to the 2t dt plus, and remember you can move the 2 to the outside once you've got it split up, right? 2 antiderivative of t to the 1/2 dt. So this moves it once. You guys are okay with that? This piece alone had the 2 attached to it, so once I split it up, that's the only one that has the factor 2 on the outside. This one's not a factor 2 on the outside. Okay, we know the answer to this. All right, this is no big deal. This is raise the power by 1, we just did it. So 3 halves, and divide by 3 halves, which is multiplied by 2/3. Times 2 is 4/3. So this is 4/3 t to the 3 halves. And I have a plus c on the end of that whole thing. So now I got a plus here. That's that plus.
Shouldn't that be a negative t and a half? 'Cause it's
No,
square
because
root.
I'm going up. Are you saying the answer down here?
No, no,
At this stage?
Yeah, shouldn't it be
No, because
negative?
it wasn't on the bottom. This is a regular 1/2 power. Standard
Oh,
radical.
okay.
Okay, so now I just gotta figure out the antiderivative of e to the 2t, and then we'll be done with this problem. So Raja said it should be e to the 2t, and it's extremely close. So let's just think about it for a quick second. If I claim it is e to the 2t, then if I take the derivative of what I believe is the answer, I should get the integrand. So what happens when you take the